Okay, so yeah, this is done. You can see here at initial points there are then there is nothing at initial point, and then as soon as there are many players are there which are not getting paid anything, but they also have got some points, and as soon we move forward, as soon the value increases, the overall performance is also increasing. So we can say yes, there is a positive relationship between value and overall. And in case of a striker, there is comparatively less valued players are there in or in play, and in case of in case of goalkeeper, there are number of players are also less, and they are comparatively getting paid less. But in case of striker, there are high possibility of getting paid more as soon the value increases, right? And the same thing we are taking with the three variables, so striker, right winger, and left winger. So that comparison is also here. So this is overall, we can say there is a positive relationship between overall score and value of those players. Okay. Now, what we can do, we can put the markers also with this. So different position will be represented with a different marker. So you can see these markers over here, and you can see marker is coming with the orange color, and left winger are with green color, and striker are with blue color. Okay, so this is also a way of implementing the same thing in more interactive way. Basically, we are implementing. Okay. Now, next is box plot. So till now, we have already seen about the most data relationship. Now, when we have to find the if there are extreme values in data or not. So at that point, we use this. Box plot. So in box plot, generally what happens when we have a box plot, let me share my paint screen and I'll draw a small diagram for you. Okay. So when we talk about the box plot, in case of box plot, what happens? This kind of box is created. This is a kind of box that is being created. Okay. And upper and lower, you can see a line going like this, and there is line like this. And upper part also there will be line like this and like this. There will be somewhere line in between like this. There will be one this line. Okay. So what this graph indicates is this point known as lowest. This point is considered as the highest value. Okay. This point is considered as the middle value, or you can say this is a average value. Okay. Then this point is there. This point is called as 25th percentile. Okay. 25th percentile, and this point is 75th percentile. Okay. Average is already known as 50 percentile. We already know this as 50 percentile. Okay. Average is there at 50 percentile only. Okay. Understood?
Okay. Okay.
So now, what can happen? What this graph represent? These are the representations in graph. Now, sometimes you can see the graph like if no, this is the graph structure. So here it is like this, and here it will be very small, and the average can be somewhere at this place, not in middle. Okay, and in some cases, there can be the case like where the upper part is at very near, lower part is lengthy, and then it can average can be somewhere like this. So what does this these thing refer? Do you have idea? Do you have idea?
No.
Okay, so let me tell you what this value is. This value is the average. Okay, this value is average, either for this one or this one, both these this value is average. Now you can see average, in this average is moving towards the high values, and in this average is moving towards the low value. So what could be the reason behind moving like this? So we can say when we have more extreme or more biased value, more biased values, then average shifts. So for example, if we have numbers like we suppose, let me open a notepad, or we'll take a text box here itself. So suppose when we have numbers like uh, 2, 3, 4, 1, 5, 2, right? And then there can be value of let's say 34 and 32 and 2. Okay, we have values like this. Now, is this visible? Let me increase the font size. When we have values like this, so at this point, what will be the average of these values? So this is 2, 3, 5, 4, 9, 110, 5, 15, 3, 18, 18 and 34, 52, 52 and 32, it should be 84 and 86. 86 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. So 86 divided by 9, and the average will be somewhere around 9, um, 9.3. Okay, this will be average. Okay, and let's suppose we have another we have another data, and this data has value of suppose 3 comma 5 comma 32 comma 34 comma 35 comma 67, and then let's suppose 23 we have. Okay, so now you can see that now the average of this will be, what will be the average? So 3, 5, 8, 8 and 32, 42, 74, 74 and 45, 119, 119 and 67, 186, 186 and 23, 209. Okay, now if you take the average of this 209 divided by 1, 2, 3, 4, 5, 6, 7. So this average will be somewhere around, let's say, 7 values, 209 divided by 7. So this will be somewhere around 20, 30. Okay, this is somewhere around 30. Okay, now as per this, if you consider, so in this part you see, if we take this data into this, so this part is at 2 and this part is at 34. Okay, no, not here. So this part is at 2 and this part is at 34. So ideally, if starting number is 2 and this ending number is at 34, so average will be somewhere around means 34 plus 2 divided by 6. Ideally, if values are equally distributed at places, so the average ideally should be somewhere around 2 to 34, 32, 16. So it should be somewhere around 18. 18 will lie somewhere over here. Ideally, it should average should be this, right? But
Mhm.
where average lying is 9.3, it is somewhere over here, right? This is the actual average, right? Ideally, it should be this, but actual average is this. In this case, you can see here it is starting at 3 and upper number is at 87. Okay. And here what's happening is, ideally the average should be somewhere around 35. So 35 will stay somewhere around here, but actual average is 30, right? So 30 is somewhere over here, right? So you can see here, because of the higher side of values, average is pulling towards one direction. Understood? Here you can see we have higher amount values are
So
more.
I'm trying to understand. So you have
Mhm.
given 2 and 34 here, and then the values down, and you are plotting the points. I mean, you're marking the average, average like 18 over there for uh, 34
No,
divided.
ideally this value should be changed. I have given this 23 number wrong, otherwise it would have gone up. I was planning this, and this value should go up towards upside. Okay.
Mhm. 1 minute. So what are these two values? It should have either one values, right? So you are taking two averages.
Mhm.
So
So
this graph shows two averages.
no, this graph is not showing two averages. This
Mm-hmm.
graph will show just one average only,
Okay.
right? But
Mm-hmm.
what I mean to say is, if your data is balanced, your data is not biased, your average line should be will be at middle, like this, right? If data is well balanced and in means equally distributed at its range, then ideally this should be the average should be in middle. So basically the box plot shows whether your data is balanced or not.
Right.
Okay.
Mm-hmm.
So for example, if you have the values like, you have the values like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And let's say 20, 22, 24, 26, 28, 30. We have these, let's say 15 values we have, and the average of these value, if you consider just this graph, this as graph, so average of this value will be 16. So this is going to be our average. You can see this is the average. Okay. So this is at middle. But if our data is like 2, 3, 4, 5, 2, 3, 5, 6, and here this is 4, 5, 6. Then suppose let's say 5, 6, 4, 3, 4, 5, and then we have value like let's suppose 45 for and 46, right? So here in this data, if you see the in this data, this minimum value is 2 and maximum value is 30. So 2 plus 30 um, divided by 2 is equal to 16, and this is matching. Okay.
Mm-hmm.
Understood. And
Mm-hmm.
here we have data, and here like let's say we have values like, once again, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, 15, and 45, 46. So we have data like this. Now now what we are doing is, now ideally in this case, this the minimum value is 2 and maximum value is 46. right? Divided by 2, the average should be somewhere around 24, right? But here your average is somewhere around 13. So this is our average. Okay. And
Mm.
let's suppose we have values like 2, 3, 4, 5, and 6, 7, 8, and let's say now we have values like 55, 50, no, 66, 77, 88, 99, and then 78, 67, 50, 56. Now here the minimum value is 2 and maximum value is 99. Divided by 2, it should ideally be somewhere around 50, right? But here ideally this is somewhere around 41. So we can see it is moving somewhere around this, right?
41 means what is 41? All divided by 2.
Sorry,
41?
not 41, this is 31. Sorry, 41.
Mm-hmm.
This should be somewhere around 40, means average ideally should be somewhere around 41, but as per the minimum and maximum value.
Mm-hmm.
As per the minimum and maximum value, average should be 50.5, but your average is less than this, right? So
Okay.
now,
Mm-hmm.
right now, average is 41.5. Okay. Here,
Okay.
the ideal average is 13. Here, the ideal average that we are getting is 16. Okay, so you can see here when we have the balanced value, the average is coming at middle. When we have the extreme value, the average is not in the middle.
Mm-hmm.
Okay, understood.
Yes.
So this is being represented by the box plot.
Okay. So
So
here 1 minute. 24
mm,
means you mark the 13. So the average is 24 means you have to mark the nearby value or the exact
no,
value,
no,
right?
I am marking the average only. This is the 13. This is the
Oh, this
average.
is 13. Okay.
Uh,
Okay.
I'm
24 is the whole
in
value
24.
divided by 2.
Yeah,
What?
24 is
Yeah,
the ideal.
average.
As per the minimum and maximum value, as per the minimum and maximum value, the average ideally should be 20, around 24. But since data is not divided uniquely,
Mm-hmm.
right? So when data is not divided uniquely, what's happening is average is shifting into towards one direction,
Okay.
right? And the
Mm-hmm.
same thing is happening means now the higher side data is more, so it is moving towards that.
Okay.
So this is basically being represented by the box plot. Okay.
Okay.
So let's come back to our this box plot. So I'm just telling you that what representation ideally it is. So here we are taking the striker and goalkeeper only, and striker and goalkeepers are being evaluated based on the parameters of values, overall aggression, and position, right? So now in case of like 84 points for a striker, it is blue, and goalkeeper is orange. So in case of a striker, you can see, let me increase it a little. So in case of a striker, you can see here the average is shifting towards downside, right? And
Mm-hmm.
in case of goalkeeper, average is going towards upside,
Mm-hmm.
right? In the
Yeah.
same way, in the same way, in at overall score of 84, you can see in both the striker and the goalkeeper, both are moving towards downside.
Mm.
Okay, so you can see here means the data is not balanced for any of the parameters. If you want, you can add more parameters over here. So like you can add this left wingers. So let's add left winger over here. So you will get one more set of this. So you can see this is left winger are not here at the 83 point. but here it is left fingers are there. You can see at 86 left finger data is much balanced.
Okay.
Yes. So in overall cases also wherever the left fingers are there, you can see data is comparatively balanced. Here this is pulled towards upside, but here it is almost in middle, and here is also it is almost in middle. So data is balanced. Okay.
Okay.
Okay. So this is what is being represented using the um box plot.
Okay.
Is this clear?
Yes.
Okay. Next. So next is heat map. So heat map is basically, it is also known as the correlation plot. What is correlation? We discussed in last class yesterday, correlation between two variables.
Relationship
We,
between two
yes,
variables we discussed, right?
yes, relationship between two variables. Basically, when how value of one behavior affects the variable
Mm,
behavior of other variable.
mm, yes.
Okay, so that's what is the correlation. So value of correlation is varies between -1 to +1. Okay, so if there is the values are or variables are highly correlated, it will be moving towards the +1. If values are highly negatively correlated, the value will move towards -1. And when the values are least correlated, value will move around zero. Okay, when very least correlated.
Okay.
Clear है? So,
Yeah.
so this here what we are doing is we are taking the comparison of five different parameters: acceleration, aggression, agility, balance, and ball control. We are going to discuss. Okay, so first of all, we are just calculating the correlation. So here, this lambda is applied, and at the last we are just calculating the correlation dot core function we are applying. Okay, and once this is applied, you can see we have got the matrix correlation coefficient. So this is between acceleration and acceleration, aggregation, agility, ball and ball control, balance and ball control. So you can see diagonal, in diagonal there is one, because acceleration with acceleration, aggression with aggression, agility with agility, balance with balance, and ball control with ball control is being compared. So that's why in diagonal it is coming one. Then there is triangle up above the diagonal, and triangle below the diagonal. You can see if you transpose the below triangle, you will get the upper triangle. Okay, can you see that? Can you see that below triangle and upper triangle? Cannot hear you anything.
Mm-hmm. No. So
Can you see that lower triangle and upper triangle are same just by transposing?
mm, no, which one? Can you please move the cursor over it?
See, this is, you can see diagonal. There is one in diagonal.
Mm.
Yes.
Yes.
Now,
Yes.
now you
Yes.
see point two
Yes.
five,
Yes.
point two five is same. 0.79, 0.79, 0.70,
Yes.
0.70.
Yes.
So
I can see.
the triangle above the triangle, so triangle above the diagonal and triangle below the diagonal are same. Okay.
Yes.
So what will now we'll just plot them in form of heat map. Okay. So the same command I am using, and at the end I am just giving SNS dot heat map, and this F is supplied over here. Okay, so you can see here the same thing is now being implemented on the heat map, and here when they are highly correlated, it is showing into the light color. When they are least correlated, the color is getting darker. Okay,
Okay.
so you can see the 0.8, these are highly correlated. 0.7, 0.67, 0.77, 0.7, they are highly correlated. When we talk about this 0.24, 0.18, so they are least correlated. And all variables are positively correlated. It's not the negatively correlated. So here, although these are near zero, but still they are positively correlated.
Mhm.
Okay, so this is what is heat map, and now here you can see this is a not is equal to
I don't
true.
see your screen. I don't see your screen.
Uh, since when you were not able to see? Uh,
Oh, no, just 2 minutes. A minute. Oh, yeah.
give me a second. Again, Zoho stop. Oh yeah, started. Mhm. My screen visible? Is my screen visible?
Yes.
Okay, so here you can observe all relationships are positively correlated. Okay, there are no negative correlations. Then there are parallel coordinates. So parallel coordinate represents the behavior in a parallel manner. So like acceleration, aggregation, agility, balance, and ball control. These five parameters, the comparison is being done for a striker, goalkeeper, and center forward. So you can see. Let me execute this. So you can see here, and there is gray color for striker, green color for goalkeeper, and purple color is for center forward. So you can see here in case of goalkeeper, aggression is less, and acceleration is more. Okay, and for agility, agility is higher for everyone, a striker, goalkeeper, and the center forward. And the ball control is comparatively less for goalkeeper, and it is very high for center forward and the striker. Okay, so it is basically representing the behavior of different type of values at different parameters. Okay, and this can be this can also be selection criteria of teams, because for a different type of player needs the different ability. So, for example, goalkeeper needs the less aggression, but it needs very high acceleration and very high agility. But in case of a striker needs the aggression more. Okay. Okay. A striker needs the balance more. A striker needs the ball control more. Okay. But in goalkeeper, aggression and ball control is comparatively less required, but acceleration, agility, and balance is highly required. So this can be a criteria of selection as well with the players. Okay.
Basically, this map is used to look forward. I mean,
Your your voice is very less.
so this map is used to for
This
what
this map
purpose?
is this map is used to track the different parameters for their need representation. So, parallel parameter plots are used to determine how different traits are distinguishable in different terms. So, like there is acceleration is there or agility is there. So, how they are working for the different types of player. So, suppose in for football team itself, one player says that I want to become a goalkeeper, but with his behavior or whatever he has played so far now, it's telling that he has more aggression. So might be when he has more aggression, so he can be less suitable to become a goalkeeper, but he can be more suitable to become either a striker or center forward. Understood?
Okay.
So basically, judging the capability of player based on their performance instead of what they are claiming.
Okay.
Okay, so these things are used for the parameter selection or the main capability selection kind of things. When people are there in the suppose teams in teams players are there, or when there is promotions, promotion kind of things are required. So one candidate is checked based on different parameters, and based on that, those decisions are taken.
Okay.
Okay. Next is swam plot. So swam plot is basically a categorical scatter plot is there, where there is no overlapping points are there. So for this one very popular data set, that is Titanic data set, is taken, and with Titanic data set we are trying to compare the data. So you know the Titanic.
Mhm.
Everybody knows the Titanic.
Yes.
So when that from Titanic, one case study was done. So that case study data has it has basically passenger ID, survive, passenger class name, sex, age, sibling, and parent, child, ticket, fare, cabin, and embarked. Okay, so now what we are doing is we are comparing the survived based on the fare and passenger class, right? We are trying to compare these two things. Okay. So by this, what we are trying to we are trying to make a scatter plot on different categories. So those categories are survived. So survived is either zero, zero means non-survived, or one means survived. Now there are different colors are there. So passenger class one has the blue color, passenger class two has the red color, and passenger class three has the orange color. Okay. Now in case of passenger class 3, if you see, so passenger class 3 people are higher in case of non-survived in comparison to survived. But in passenger class 1, there is higher there is higher number of people who survived in comparison to the people who are not survived. Understood?
Mm-hmm.
So this can represent that the passengers who are traveling in first class has the higher probability of survival.
Mm-hmm.
Okay, and the passenger class 3 has the less possibility of survival. Okay, so these things can be used. We'll see the Titanic case study again in detail. We'll do in EDA the detailed case study on the Titanic. so that you can understand the
Okay.
different traits, how this case study works. So this is all about the data visualization. You can have this with you and you can practice it.
Okay.
Okay, once you will practice, you will understand how these things are working. Mostly, in case of univariate, you will be using these charts, and in case of bivariate, you will be using the scatter plot and pair plot, basically. Not more than that. Very rarely, other graphs are being used. The most used graph are this histogram, bar chart, line chart, then a scatter plot, or stack plot or pair plot. That's it. Okay.
Okay.
In case in inside the Python, mostly these graphs are being used. When you will go the other software or visualization tools like Power BI and all, so then you know how there are so many types of graphs are there. You yourself have used those graphs.
Yes. So we
Okay.
don't have this histogram.
Uh,
So yeah, scatter